Alright guys, we are in chapter 7.5 here, which is again over factoring binomials. It's special binomials, or special products, I guess is the way they phrase it, because it's going to end up being what's called a perfect square trinomial. They go through, it is standard A.SSE.2, I think I said that already, I'm not really honestly sure. They define it. A perfect square trinomial means it's the same quantity times the same quantity. And so they give you examples here. Recognizing and factoring perfect square trinomials. There's your example. Notice that x squared has a square root of x and 36 has a square root of 6. And the middle term is double the square root of the last term, or the constant. So that kind of pattern seeking that we always talk about within algebra and math. Like, you notice a pattern, I wonder if this is always true. It is in this situation. They talk about that here. I like the first example they gave you because 9 is a perfect square, so the square root would be 9, and 4 is a perfect square too, but double 2 doesn't give you 12. You gotta think about 3 times 2 is 6, and 6 doubled is 12. So again, you're just watching for patterns. Let's see here. Do they have any check it outs? Yeah, I'm assuming they do. So second example here, 4x squared has is a square root. It's 2x. 9 has a square root. That's 3. Notice how the trinomial has a minus and the plus, so I know that my parentheses are going to be a minus minus, because two negatives make a positive in your constant, and add together two negatives and you keep a negative in the middle term, the monomial there. So let's see, 2x times 2x is 4x squared, and 3 times 3 is 9. If I do 2x times 3, that's 6x, and then double that would give me my 12x. Obviously it's negative because we started with a negative. So let's look at these check it outs. We'll just kind of talk about them, and I'll write down some chicken scratch on the side here to see how I'm thinking. If we talk about 1a, x squared plus 4x plus 4, pardon my plus sign there. They start off with something simple in this check it out. The square root of x squared is x. The square root of 4 is 2. So I just got to double check it if I'm squaring this. Square the first term. Find the product. X times 2 is 2x, and double it. That's 4x. And square the last term so it matched. So that would be my answer for check it out 1a. 1b, we've got x squared minus 14x plus 49. So I know based upon it's a minus plus trinomial, so that means my binomials are going to be subtract in the middle. The square root of x squared is x, the square root of 49 is 7. So I'm going to just double check everything. Square the first term is x squared. I'm going to find the product. X times negative 7 is negative 7x, and double it, that's negative 14x. And then square the last term. Negative 7 times negative 7 is positive 49. So that perfect square binomial worked there. 1c, I'll have to clear some writing here. We've got 9x squared minus 6x plus 4. So the square root of 9 would be, the 9x squared would be 3x. I know that it's a minus in the middle of my binomial because the trinomial has a minus and a plus. And then the square root of 4 is 2. So now I'm just going to check my answer. Square the first term is 9x squared. I'm going to find the product. 3x times negative 2 is negative 6x. And then I'm going to double it. That's negative 12x. And then I'm going to square my last term. That's 4. So if you notice here, this does not match the original. So determine whether each square is a perfect square. Determine if each trinomial is a perfect square. If so, factor. If not, explain. This one is not a perfect square because the middle term is not possible given the square root of 4 and the square root of 9. Check it out, letter C. 1c, we got 9x squared minus 6x plus 4. The square root of 9x squared would be 3x. I know since it's a minus plus that my middle term is going to be subtract, or my operation, is going to be subtract. and the square root of 4 is 2, so now I'm just going to double check it. Square of the first term is 9x squared. I'm going to find the product. 3x times negative 2 is negative 6x. Double that, should be negative 12x. And then square the last is 4. I feel like I just did this. Maybe I skipped B. Either way, this does not work for C. They've got example 2, problem solving application. Go ahead and read through that. You got that on your own. And then the next page keeps going with the check it out, or the example. They got to check it out down here. A company produces square sheets of aluminum. Each one of these has an area of 9x squared plus 6x plus 1 square meters. The side length of each sheet is in the form cx plus d, where c and d are whole numbers. Find an expression in terms of x. For the perimeter of the sheet, find the perimeter when x equals 3. So you are doing multi-steps here. The original trinomial is 9x squared plus 6x plus 1. I know because it's a plus and plus trinomial that my middle term, my operations can be plus. The square root of 9 is 3. The square root of 9x squared is 3x. The square root of 1 is 1. So we're going to multiply everything out. Square the first term. That's 9x squared. I'm going to find the product. 3x times 1 is 3x, and I'll double it as 6x. And then square the last term. That's 1 again, so it worked. So the directions said the side lengths of each sheet in the form of cx plus d. So we just did this, cx plus d right there, where c and d are whole numbers. Find an expression in terms of x for the perimeter of a sheet. Find the perimeter when x equals 3. So if the square has a side length of 3x plus 1 and x is 3, 3 times 3 is 9 plus 1 is 10. And then they want you to find the perimeter of that sheet. So the perimeter would be 40 meters, because 10 times 4 would be 40. That's how you would do that. I like how this section goes into the difference of two squares. It talks about that down here. If you've got a squared minus b squared, an equation in that form, that's equal to the quantity a plus b times the quantity a minus b. So this is another kind of pattern-seeking shortcut that they're trying to point out to you there. They've got examples on the next page. X squared minus 81 would give you the quantity x minus 9 times the quantity x plus 9. They do a good job showing how they got that here. The 9 came from the square root of 81. We've got 3p to the fourth minus 16q to the second. The square root of 3p to the fourth would be 3p squared. The square root of negative 16q squared would be a positive 4q and a negative 4q. So they talk about that here. They give you the answer. C, that's x to the sixth. The square root of that would be x to the third. And negative 7y squared is not possible because negative 7 is not a perfect square. Therefore, you cannot do it. It is not the difference of two squares, and they do a good job of pointing that out here. The check it out says determine whether the binomial is a difference of two squares. If so, factor. If not, explain. So 3a, I'm going to go ahead and I'm going to switch the order of that to negative 4x squared plus 1. And then I'm going to factor out the negative 1 to give it 4x squared minus 1. And then I'm going to tell you an answer of no, it's not a perfect square, because negative 1 is not a perfect square. Giving you a second for that to sink in. 3b, we've got, I think that's a p to the 8th. I'm not honestly sure. We've got p to the 8th, holy terrible 8, minus 49q to the 6th. So I'm thinking about the square root of p to the 8th is p to the 4th. It's a plus and a minus. Hold on, I just did 3a wrong. I'm going to go back and do 3a here before I screw this up again. So it was -1 times the quantity 4x squared plus 1. Excuse me, minus 1. When I factored out the minus 1. So then that would be -1 times the quantity 2x plus 1 times the quantity 2x minus 1. So that is the difference of two squares. So that would be the answer for 3A. Pardon my mistake earlier. 3B, going back to it, p to the 8th minus 49q to the 6th. Let's see. That would be p to the 4th plus 7q to the 3rd times the quantity p to the 4th minus 7q to the 3rd. So the square root of p to the 8th is p to the 4th, the square root of 49 is 7, the square root of q to the 6th is q to the 3rd. And it is a difference of two squares because those terms would cancel and it would give you the original trinomial, or not trinomial, binomial. 3C, clear this off again. The square root is, let's see, the original 16x squared minus 4y to the 5th. The square root of 16x squared would be 4x. And then the square root of 4 would be 2. The square root of y to the 5th is not possible. So this is not the difference of two squares. So 3C did not work. That's how I was able to tell the difference. Hopefully that helped. Next page in this section is your exercises. I assign you problems 14 through 39. As always, good luck and let me know if you have questions.